Section 9.7. Our objective today is I can solve problems involving lengths of chords, secant segments, and tangent segments. So we're going to start out with the chords. Notice that P, Q, and SR are chords of the circle in this picture. And segment PX and segment XQ are segments of chord PQ. Okay, and RX and XS are segments of chord RS. Okay, so the following theorem says that the product of the segments of one chord equals the product of the segments of the other chords. In other words, length of PX times length of XQ has to equal length of RX times length of XS. And the theorem actually says this. When two chords intersect inside a circle, the product of the segments of one chord equals the product of the segments of the other chord. Okay, so for instance, if I, here's an example. If I have chord A, B, and chord D, C that intersect at point P, and I know that AP is 4 and PB is 6 and CP is 8. There should be a D up here. So find the length of PD. Okay, well, the product of the chord of the segments of one chord equals the product of the segments of the other chord. So we'll let this be X. So 4 times 6 has to equal X times 8. So 24 equals 8X. Divide by 8, so X equals 3. So the length of PD has to be 3. Okay? All right, on to the next one. Okay? So in this one, I have a circle, and I have segment, or I have secant DF, and I have secant FH. Okay? And then we have, this is point E, and this is point G. Okay? So segment DF and segment HF are secant segments. Because remember, a secant is a line, so the secant would be line FD. But secant segments are the pieces of the secants. Okay? And we have two different kinds of segments. We have the segments outside the circle and the segments inside the circle. So the external segments would be segment EF and segment GF. Those are the external segments. Okay? And so the following theorem says that the whole segment, so the whole segment would be DF, it should be length of DF, times the external segment has to equal the whole segment times the external segment. Okay? So, in other words, in words, it's whole times external equals whole times external. Okay? And the theorem actually says this. When two secants are drawn to a circle from an external point. In our picture above, the external point is point F. The product of one secant segment and its external segment equals the product of the other secant segment times its external segment. Okay, so an example of this one, let's say I have this circle and I have, this is point R, this is point P, and this is point Q, and then I have RS, and this is point T. And I know that PQ is 9, and I know that QR is 3, and I know that TR is 4. And I want to find the length of SR. Okay? So I don't know ST, so I'm going to let that be X. So remember, it's the whole secant segment, so PR would be 12 times the external is equal to the whole, so the SR would be X plus 4 times the external. So I get 36 equals 4X plus 16. Subtract 16 from both sides. I get 20 equals 4X. Divide by 4. I get X equals 5. So the length of ST is 5. So the length of SR has to equal 5 plus 4, or 9. Okay? All right, and then the final theorem. In this one, we have a circle, and we have a secant segment, which is PC, and we'll call this point B. And then we have a tangent. So A is a point of tangency. So PA is a tangent segment. And PC is a secant segment. Okay? And so the following theorem says, because PC is a secant, we know it's the whole secant, so PC times its external is equal to, and in this case, it's the whole tangent times its external, but it's the same thing, so it's going to be times PA squared. Okay, So it's whole times external equals tangent segment squared. Okay? And the theorem actually says this. When a secant segment and a tangent are drawn to a circle from an external point. And so our external point in this case is P. The product of the secant segment and its external segment is equal to the square of the tangent segment. Okay, so a quick example of this one would be, I have tangent QR and secant RT, which intersects at S. And I know that RT is 25, and I know RS is 5. And I want to find QR, so we'll let that be X. So it's whole times external equals, and QR is a tangent, so it's the tangent squared. Okay, so take the square root of both sides, so X equals 5 square root 5. Okay, so QR has a length of 5 square root 5.